Kulkarni. I'm a PhD candidate with the ECS department, and this is a video to demonstrate a demo video basically in support of my application for the Electronics 2 course, the ECS 3420 course offered by the ECS department. Without wasting any further time, let's dive directly into the and have a look at what the agenda for today's class would be. So the agenda for today's class would be the different amplifier circuit configurations, and we'll focus today on the common emitter amplifier only. And then if you have any questions and answers, we'll discuss those questions or a class discussion. Having said this, if you have any questions when we are discussing or during the course, during the class, do not hesitate to ask me, and I'll be happy to answer your questions. So let's talk about the different amplified circuit configurations now. Basically, before starting that, I'll just give you a rough idea of what transistors are and what different types of transistors there are and how we classify them. So basically, there are two types of transistors. One is an NPN transistor and the other one is a PNP transistor. Today's focus will be on the NPN transistor. Now, just to give you an idea of how to differentiate between an NPN transistor and what are the different terminals of a transistor, let's have a look at this circuit over here. If you see the arrow over here, if you have an arrow which is outgoing, that is a NPN transistor, and the three terminals of a BJT or a transistor are a collector, a base, and an emitter. And with this comes today's main focus, or the hero of today, that is the common emitter amplifier. Now, about common emitter amplifier, this is how a common emitter amplifier looks like. If you see, the input here is given through the base, and the collector gives out the output. The output is basically collected through the load resistance over here. This is how the circuit of a common emitter amplifier looks like. Now, why this is called as a common emitter amplifier? Because it is grounded. The emitter is grounded and common to both the base and the collector. Now let's go ahead and dive immediately into what are the different characteristics of this emitter amplifier, or what outputs do we get for this common emitter amplifier. These are the different characteristics. Now, as I said in the previous slide, as in the previous slide while we were looking at the circuit, the input is given through the base and the output is collected through a terminal, of course, and the emitter is grounded and basically common to both. Now, to talk about voltage gain, current gain, power gain, let me tell what a voltage gain is, a current gain, and a power gain is. For that, let me take out my whiteboard immediately. Now, voltage gain, which is given by AV, please pardon my writing over here, this is your AV, that is your voltage gain, and it is defined as your ratio of output voltage over input voltage. This is how your voltage gain is defined. It's a ratio of output voltage to input voltage. Similarly, your current gain, that is AI, will be equal to I'm sorry about that. Okay, let's cross this. I'll show you. Your AI, that is your current gain, is given by input current over your input current. I beg my pardon. It is defined as the output current over input current. That is your current gain. And your power gain, now as you know, your power gain is defined in two ways basically, because of the definition of power. Your power is always equal to voltage times current. So if you want to calculate your power gain, it can be defined in two ways. Number one is it is a product of voltage gain and current gain, or you can also say the output power over input power. That is your power gain. Now, with this background, let's look at the characteristics of the common emitter amplifier. The common emitter amplifier has got a mid-range voltage gain. The output voltage to input voltage is is this mid range. Your current gain, the output current to input current, is again mid range, but the power gain here, guys, is high range. Okay, uh, it's got an input impedance and output impedance, and both are the mid range mid range. Both lie into the mid range. Okay. One very important characteristics of the common emitter is the output signal is shifted by 180 degrees. Now let me show you what that means. Okay, but is it is amplified, of course, but it is inverted. Now let's say this is your input voltage. Your input voltage is, please excuse my diagrams over here because I'm using a mouse, and your output would be somewhere this way, amplified but inverted. This is the most important characteristics of a common emitter amplifier, which the other two configurations, that is the common base and the common collector, which we would be doing later, do not have. So this is one very important characteristics of the common emitter amplifier. Uh, that's it. If you have any questions, let me know, please. Thank you.